Hello everyone, I again welcome you all in the video series of Raspberry Pi. In the last video we saw how to connect the LED with the Raspberry Pi and how can we control the LED using the Python IDE available on the Raspberry Pi, and we can control the LED giving the particular time duration to switch on and off. Okay. Now in this lecture we are going to see how to connect the basically how to control the brightness of LED using PWM. So PWM is pulse width modulation. Pulse modulation. So pulse width modulation is basically used for the analog values, and through PWM we can gradually increase the brightness of the LED from 0 to its highest maximum point, and also we can gradually decrease the brightness from the highest to the lowest point. Okay. And also using PWD, there are various applications of the PWM. We can also control the speed of the motors. We can increase and decrease the speed of the motor using PWM. So here we are going to see how can we control the brightness of we can increase or decrease the brightness of the LED using PWM in our next experiment. Okay, so let's begin. So this is the GPIO pin diagram. We have already explained in the previous video that there are 40 pins available at the Raspberry Pi, and these pins are used to connect various various type of sensors to the Raspberry Pi. So here obviously we are going to connect our LED. So we will use one GPIO pin and one ground pin. So you can choose pin number 3, pin number 5, pin number 7, 11, 13, 15. Okay, these are the GPIO pins. Okay, so here you can connect the general purpose input output. These pins are basically known as general purpose input output pins. So here we can connect the our LED, our data lines of the LED, and also another end of the LED will be connected to any ground pin. Okay, so pin number 9, 14, 20, pin number 25, pin number 30. There are various ground pins given in the this Raspberry Pi. So let's see what will be the circuit or what will be the connection. Okay, so this figure shows the circuit diagram for interfacing LED. This is similar as already explained in the previous video, that we have used here we have used a breadboard. Okay, in a breadboard we use a resistor of 220 ohm. We can skip the resistor also. These resistors are basically used basically control the voltage level, and if the voltage is high, it may be the possibility that LED will be damaged. So if the voltage is not issue, you are supplying proper voltage to the LED, so you can just skip this this resistor. Okay, so simply you can connect the positive point of the LED to the GPIO pin number 2, that is board pin number 3. So here you can see this is board pin number 3, this is pin number 1, pin number 2, pin number 3. So this is board pin number 3 and GPIO pin number 2. Already I have explained you that we can numbering in the programming we can use board pins or the BCM. Okay, so if you are using the board pin, then this is pin number 3, and if you are using BCM, then this is GPIO pin number 2. Okay, so this will be the connection. We have connected the LED ground pin with the pin number 6, and LED out means the data lines of the LED with pin number 3, that is GPIO pin number 2. So this will be the connection. Okay. Now after connection we will write the program. Obviously this is the program. So whenever I will program it, I will explain you, but here I will briefly explain how this brightness will be controlled. Okay. So here the first line shows that import rpi.gpio as GPIO. So RPI GPIO, we have imported one of the library into our program. The reason is that because we are using the GPIO pin for giving input and output. That's why we have imported RPI.GPIO. Okay. We have also imported a time library. I will explain why I have included this time library. And in the third line, GPIO.setMode bracket GPIO.board. Basically, we are, as I already told you, that we can use this GPIO pins as a board pin or the BCM. Okay. Here, if we are using the pin as a board pin, in that case we have to set it that we have to told the Raspberry Pi that we are accessing the pins according to the board numbering pin, not the BCM numbering. Okay. So that's why we have to set the mode of the Raspberry Pi, whether we are going for the board mode or the BCM mode. The fourth line is GPIO.setup bracket 3.GPIO.out. This means that we are using board pin number 3 for input and output. Okay, obviously for the output. Okay, that's why we have to set up that pin number 3, board pin number 3 will be act as an out pin. Okay, GPIO.out. Now I have used a variable p in which p is equal to GPIO.pulse width modulation 3.100. Here 3 is showing the board pin number and 100 is basically percentage. Basically 100% means maximum brightness of the LED. Okay, so 100 will show the maximum brightness of the LED and 0 will show that our LED is off or the minimum brightness. Okay. In the next line, P start 0. That means we are starting from whenever we are starting from the low level. That means LED is in off condition. Okay, and after that we will gradually increase the brightness of the LED to the maximum 100%. Okay. While true, because we are using the infinite loop, the brightness will increase gradually and decreases, then increases, then decreases. Okay, and this will be go in infinite loop. That's why while true shows that we are using the infinite loop. For x in range 100, p dot start x time dot sleep 0.1. Here what we are using, that we are using the value of x from 0 to 100, and p dot start x means the first value will be 100, it will increase by 1, the value of x will be 2, it will increase by 1, the value of x will be 3, and up to 100 means the LED brightness will the LED brightness increases from 0 to the 100. Okay, and here I have used time dot sleep 0.1. That means we are giving 0.1 millisecond with increase in the increase by 1. If we are increasing the loop by 1 and we are giving the time duration of 0.1 millisecond, so it seems us that brightness increases in analog way, but actually it is increasing in every 0.1 millisecond. The brightness will increase by 1. Okay. In the same way, last 3 lines show the brightness decreases from 100% to the 0. Okay, that's why we are use P dot start 100 minus x. Okay, so when the value will increases, the value of the x will be increases, the brightness will be decreases. Okay, and here also I have used time dot sleep 0.1, means at 0.1 millisecond of interval the value of x will be decremented by 1 and the brightness will be decreased gradually from highest level to the highest level to the lowest level. Okay, so let's see the connections of the Raspberry Pi and start the programming. Okay. Okay. So let's start the connection of LED brightness control. Okay. So here again I am having the breadboard. Okay, and of course the LED. Okay. So what I will do, this time I will not use the register. I'm just leaving it because I want to get the maximum brightness of the LED. So that's why I'm just leaving or omitting this register for in the connection. Okay. So let's start. First of all, we will put this LED into the breadboard. Here, the longer wire shows that is the positive end, and this one smaller one is the ground of the negative point. Okay. So just put it here in the breadboard. You can put it um, in any holes that are given into the breadboard. Okay. So just insert it. Okay. Now we have inserted our LED into the breadboard, and this one is the positive one, and this is the negative one. Okay. Now we will connect our wires, male to female wire. This is the positive, so I will insert in at any point, for example here. But make sure that it will be inserted at the same point line, so that because every vertical lines of the breadboard are directly connected to each other. Okay, and this is the negative one or the ground one, so I will put it here at the next end of the LED. Okay, so here I have inserted my wires on the breadboard. Now I will make the connection with our Raspberry Pi. So so here this is the data line, so I will put it into the pin number 3. Okay, yeah, so I have inserted into the pin number 3. Okay, now I will put it into the pin number 6, that is the ground pin. Okay, pin number 3 is basically the GPIO pin, and pin number 6 is the ground one. Okay, so I will put the another end of the LED at the ground pin. So pin number 6 is the ground one. So I have inserted the uh, next wire, uh, that is the ground wire, at pin number 6. Okay, so pin number 6 is the ground one. Okay, now the connection is over, and now I will give the power supply to our Raspberry Pi. So power supply, I used only the charger, simple charger that we use for charging our mobile. But basically that charger is uh, this is the point that I will use. Okay, so I will insert it. I will give the power. Okay, switch off it. Yeah. Now the connection has been over. Now we will switch to the program. Okay. Hello everyone. Uh, so now we are going to see the program of to control the brightness of the LED using PWM. Okay, that is pulse width modulation. Okay, so let's begin. Um, for that I will open the VNC. So you can see here the icon of the VNC. I will click it and let it start. So it is asking for the authentication. So username is Sheesh and I'm going to enter the password. Okay, now it's connected. Okay, okay. Now we start the programming. We have already done the programming of LED. Now we will start the programming of to control the brightness of the LED using pulse width modulation. Okay. So here what I will do. First of all, I will enter. I will include the library of rpi.gpu GPIO because we are getting the or sending the output at the GPIO pin. So that's why I will import rpi dot GPIO as GPIO. Okay. So I have imported this because we are sending the output signal at the GPIO pin. That's why we have to include rpi.gpio in my Python program. Okay. Now also I will import time function because we will gradually increase the brightness of the LED in 1 millisecond of interval, and in the same way I will gradually decrease the brightness of the LED in the interval of 1 millisecond. So here I am using the time for giving the time interval. That's why we are importing the time library also in my program. Now I will we have to set the mode of the board. Okay, whether we are uh, uh, using the pins at the board pins or either we are using the pins of the Raspberry Pi in GPIO. So we have to mention here whether we are using board pin numbering or GPIO pin numbering. So in this case, I will use board pin numbering. So I will use GPIO dot set mode. Okay, set mode, and I will use GPIO as board pin. Please ensure that you use small letters or capital letters as per the sentence given. Okay, so that's why if you are not using, in case of capital letters, you are using small letters, or in the case of in place of a small letter, if you are using the capital letter, it will give you error. Okay. Now we have set the mode. Okay. Now the next command is GPIO dot setup. What we are going to set up? We are going to set up the pin number. Okay. So pin number 3, I am using, as already shown you the connection, that I will use pin number 3 as the output pin. Okay, so I will use 3 dot GPIO dot out. Okay, because we are using pin number 3 of the board of Raspberry Pi as an output port, output pin. Okay, that's why we have set up 3 comma GPIO dot out. Now I will use a variable p is equal to GPIO dot PWM 3.3 comma 100, where 100 represents the maximum brightness of the LED, 100%. Okay, so we will start from the 100% to the and will decrease gradually to the minimum 0%, and then we will increase gradually the brightness to the 100%. Okay, now P dot start 0, we will starting from the 0. Okay, while through infinite loop, and means this program will run until unless we stop the program. For x in range 100, what it means that for x in range 100, that means we will start from 0, and the value of x will be increased. For example, x is equal to 1, then x is equal to 2, then x is equal to 3 up to 100. Okay, and also you use time dot slip of 0.1 means 1 millisecond. Okay, so and again I will just copy it. So this three lines says that we are increasing the brightness from 0 to 100. Okay, and here 100 minus x, that means we are decreasing the brightness from 100 to 0. Okay, okay, that's all. Program is over. So here I am just repeating, we have included the R5.GPIO library because we are using the GPIO pins for input and output. We have also included the time function, time library, because we are giving the time interval of 0.1 millisecond. That's why I have included. Now in third statement, we have set the mode of the GPIO as the board pin number. Now we have set up 3 as the output pin. Now we use the function PWM and at pin number 3, and its maximum value will be 100. We use a variable p such that p dot start 0. This means we are starting from the 0. While true means this is an infinite loop, that all statement comes into the while loop. Okay, and in these 3 lines we are increasing the brightness, and in 3 lines we are decreasing the brightness. Okay, that's fine. Let save it. Let name is LED PWM. Okay. Now it has been saved. Now run the program. Okay, run. So there is some error. While truth, the yeah, it will be capital letter. Okay, save and then run. Okay, now it is running. Okay, this is a simple warning. You can ignore it. If you don't want this warning, that simply insert this statement. This will ignore the warning. So let's say whether the LED is blinking, the brightness of LED is uh, increasing or decreasing gradually or not. So I'm switching the screen. So here you can see, yeah. So here you can see the brightness is maximum. Now it is decreasing. Okay. Yeah. Okay. Now it's again increasing. Okay. Clear. Now it is decreasing. Okay. I will show you. It is increasing and decreasing. It again increasing. Okay. So now in the next lecture we will see the next program of I think the brightness sorry, the temperature and humidity monitoring for that. Okay, thank you very much.